The open source Faraday cage bill of materials calculator is based upon a design used in several labs, with the structure of the frame consisting of 80-20 T-slot aluminium extrusion rails with 30mm sides. These rails can be ordered in pre-cut format to save time during assembly. The rails are assembled by clamping the pieces at right angles using 90-degree connectors and using pre-cut copper mesh as the isolation material. The copper mesh is clamped into the frame by compatible infill strips. The purpose of this document is to calculate the bill of materials, including the quantities and the lengths of extrusion rails you need to order, as well as the dimensions of the copper mesh and the fixings. These calculations are based upon the desired design of your Faraday cage, with a few options to choose from, as well as your custom dimensions. After assembly, the copper mesh panels are interconnected with conductive wire in order to make the whole cage structure into a single conductive unit, which can be grounded to the central grounding point. Assembly should not take more than 2 workdays if you have all the components laid out. So let's look at the spreadsheet in the first thumbnail. Some of the cells in the spreadsheet are locked for editing. This is to prevent the user from accidentally changing the formulas. If you intend to make some changes, the worksheets can be unlocked by using the password noted here. In this section, you enter the preferred final dimensions of your cage. If you need to fit your cage around an optical table, we recommend that you select depth and width dimensions that are 11 centimeters greater than that of the table's breadboard. This will give you 2.5 centimeters of space between the breadboard and the cage perimeter, enough to guide cables and tubes through, and to prevent direct contact between the floating table and the cage frame. The drawings in this section indicate terminology used to describe the different frame parts throughout the document. To select which design would be best for your situation, you can scroll through the different color-coded designs listed on this first spreadsheet. Comments are made above each design about the instances when a particular design would be most appropriate. Once you've decided, you can navigate to the correct thumbnail for your chosen design for a complete list of all components you need to order. Thumbnails 3 to 6 list the different designs we included in this document. When mounting a Faraday cage around a pneumatically damped optical table, it is recommended not to mount it directly onto the breadboard. This adds unnecessary weight to the table, takes away some space on the breadboard, and may change the center of gravity on the damping system, resulting in reduced performance of damping. It is therefore better to have a freestanding cage with optional stands. The length of the stands is typically 30 to 60 millimeters below the floating height of your optical breadboard's surface and can be entered in the cage dimension section of the document. Since most users will use the 2-door design with mid support, we'll use spreadsheet 3 as example in this explainer video. Here, you'll see schematic drawings that show what the different panels will ultimately look like. It also lists the exact dimensions and quantities of the materials you will have to order. In the second thumbnail, you can see some suggestions for suppliers. We have used these suppliers before, but feel free to use alternative suppliers if it makes more sense. We'll continue to add supplies to future revisions of this document. The spreadsheet displayed by clicking on the Assembly Steps thumbnail lists the steps necessary to assemble all the panels. Once the panels are fully assembled, you can download the completed panel assembly manual in order to finalize the cage installation. For questions or suggestions, please comment in the video below or send an email to info@nerogig.com.